Every time the software world is taken by a new wave and a new way of doing things, everybody gets really excited and thinks this is a golden hammer, it's going to solve all our problems. That's not actually the case. I think we're sort of slowing our way forward. This talk is an interesting one because microservices have huge benefits and they do work really, really well in practice, but there is a whole series of challenges around them. And it's really interesting to hear from Fred George, our next speaker, how some of these challenges manifest. We were really lucky to meet Fred at the Node.js meetup 2012, 2013, where he first introduced this concept of microservices. Fred has been practicing microservices for quite some time, first at Forward Internet Group in the UK and then at the Daily Mail. So he's probably made more mistakes than any of us around this stuff. So Fred George, ladies and gentlemen.
Yeah, actually, it predates that because I've been trying to do these services around 2005, and I would say my first implementation was probably at General Motors around 2006 and 7. Was where I did my first microservices. Interestingly enough, then I moved to London. My team back in the U.S. actually put a paper together for the conference, for an internal conference for ThoughtWorks. It's talking about microservices. It actually got second prize that year, and it actually, the paper was about why microservices is a really bad idea. So I guess, maybe I'll have the last slide, yeah. So a little bit of why did microservices kind of pop up? Because it actually, if you look at it, and Richard and I were able to attend the Berlin conference last week or so to talk about this with lots of different people. And the idea is actually sprung up in parallel in lots of different places. And I think it's sprung up in parallel because of the same factors that's caused it to happen in areas that I've worked in. And one is it's sort of a magic confluence or a perfect storm of technologies that sort of come about. And sort of is partly the cloud because we want to have machines to run on. We've got better languages to do that. And we have access to an amazing amount of bandwidth. You go into one of these server racks and you've got a 50 gigabit backplane on that box. You can send messages back and forth with almost no latency whatsoever. So the overhead of these message passing, in reality the real configuration doesn't exist. And people said, wow, this is kind of nice. It allows me to sort of get rid of the concept of having to buy boxes and do planning and everything else associated with that. But also the business also sort of had its perfect storm, and that was a need arose for microservices. And a lot of it had to do with the robustness needed in our systems. And our systems were getting larger and larger and larger. When I started writing code back in around 1968, a large program was 100 boxes of cards. And a box of cards, you've never seen them probably, 2,000 statements. That's a large program. I mean, we laugh at such things today. And to some degree, the techniques we learned back then of how to write programs don't work when you're writing millions of lines of code. And so to some degree, the complexity of our programs have gotten larger and larger over time. And so we're having to go back and say, instead of building a perfect program, we have to build a robust program, because it can't be perfect. We have to handle that situation. And I think that business was driving some of the things in microservices. Of course, you always say this, we've said it since the 60s and 70s, business is getting faster. We said that in the 70s it was true, said in the 80s it was true, we keep saying it, it's still true. And the other thing that's really, really wicked right now, and particularly because of the cloud and stuff, is the entry barriers for a lot of businesses is dropping. You can get a competitor coming off the street and attacking your core business very easily. Just ask the hotel chains, because Expedia and Hotels.com have a larger cap value than any of the hotel chains. And all they do is sell the other hotel's room. They don't even have any rooms of their own. And they still have a market cap higher because the entry barriers are slow. So that's kind of why you see Netflix comes up with microservices. Adrian, I'm sure your system came up on its own. You see that Richard talked about his guys sort of removing this stuff. And we've seen it happen in 3 or 4 companies of my own. So I think it's happened because of these factors. So I've looked at sort of, in this year my sort of talks are going to be around the concept of, okay, now that we've got some experience under the belt, what should we be watching out for? So I have my list of challenges as well. They're not the same as Adrian's. The first challenge is really around the database. And this is the one that I have the most trouble with when I go into larger companies. In fact, I was talking to one of the hotel chains. I was meeting with their chief architect early in the engagement. And I sort of put the question out there, says, how many databases do you ever have? And he sort of said very sheepishly, we have 3 operational databases. We're trying to get back down to 1. And I said, well, the real answer is probably more like 300 is what you need. He was shocked. It's actually the last conversation we ever had with him was that. I wasn't invited back after that, which is okay because apparently after my meeting he was going off to the consulting firm that's doing all their IT work to help them understand the new waterfall process. And I was not going to be part of that either. So we had nothing in common. And one of the things that we again heard at the conference is deconstructing the database is almost your first step to getting there. We were hearing from Chad Fowler, 6 Wonderkinder. And what Chad said was the first thing he needed to do was, into his gigantic Rails app, was kill the joins. Let's get rid of all the joins. Let's start carving that database into small pieces before we even start thinking about microservices. Well, let's break that thing. Because what was killing them was Rails trying to hit the database, trying to run really complex queries, and the performance was going to hell. So how many databases do you need? Well, again, the Fortune 100 guys love this concept of your database is your entities. These are operational entities. You got to have it's got to be consistent. We have to be perfect. We have to be auditable. So they want as few of these as possible. In the microservice world, we go the other side, which says we want a database per service. In fact, my definition of microservice is a shared database. If more than one piece of code shares a database, it's part of the same service. More than one API on the same service. But that is the granularity I'm looking for. And that allows you to pick the right database for the right need for that service. If you're talking about the database that's going to serve the enterprise, it's got to be transactional. It's got to be perfect. It's got to be gorgeous. Which means every service has to worry about that. But what we found out with microservices, the experience I've had so far, use the database as appropriate for the service. Most kids need a key value pair. That's more than enough. Sometimes they get a little Redis database that's actually just a cache of information. That if you throw the cache away, it can rebuild itself. And we found out only about 1 out of 10 of these services actually write to their database. Most are actually providing information from their database, which we fed to an overnight feed. And only about 1 in 10 of those are transactional, which means only 1 service out of 100 tends to be transactional. So let that guy worry about the ugly database and worry about SQL Server or whatever it's going to be. All the rest of it can have a much more comfortable, easy life with a database of choice. So that's one of the observations there. And I've drawn these pictures. You can see animations on the web of this in action, but this is sort of a bus-based microservice system. And you look at this little box and say, yeah, this is the offer service that's going to post something to the web on behalf of a page. But you start carving up into that, you start looking at it and says, yeah, there's also lots of little parts of this thing. There's one part that basically says, oh yeah, we have a need, and expresses it on the bus. There's another part that's listening for that need, and putting that together. Another little virtual machine, another little piece of code, very tiny piece of code. It's caching, the solutions it's getting back in a Redis database. And yet there's a third part of that, some sort of responder. If you're working with an old browser, it's going to sit there, wait 300 milliseconds or so, pull the best answers it finds in the Redis database, push it back to the workstation. You can run a different version of that if you have a smart browser. You can actually push the data live to it, carousel style. You use a different one, again, for iOS or Android. A different little piece of code. But all these would be put together in my world into a service because they're all basically sharing a Redis database. Similarly, you could have something over here that says, my job is, I'm going to tell you whether Sally is a platinum member of our frequent renter club or not. And that's his job. Very small little job, has a database to do that. So again, if you open that up, you look at it, you'll have a little piece of code that basically is listening to the bus and trying to pump out, here's Sally's platinum. And it's got to get that data from somewhere, some little key value store that we have stashed away here. So you got a little key value store to put that. Of course, you got to prime the key value store periodically. Because I don't really care for this being too much real time, I'm comfortable doing a nightly ETL process. Pull that up. So if Sally turns platinum at 8 o'clock in the morning, I don't mind waiting till tomorrow to make her platinum in this part of the system. I can live with that. But by the way, it may be that Sally's not a member at all, in which case I want to sort of maybe publish something back on the bus that says, can you get her to join? Yet another piece of code. Again, sharing one database, still in my mind one service, but probably running on 4 different virtual machines or 4 different containers. So that represents kind of the database challenge, the first one you run across. Negatives, well, you run across basically in the people who are doing this so far, sort of a philosophy of whether you're going to be fundamentally synchronous or asynchronous. And these are fighting words. This is like, you know, Emacs versus Vim versus your favorite GUI editor. This is passionate subjects. And the thing is, basically everybody kind of agrees on some fundamental principles here. So we all basically agree the services should be really small. They should have their own database. You want to exploit the concept of having appropriate language to develop these things in. We're not stuck with one universal language here. We like the idea of multiple versions of running in parallel. That we're not trying to take down and make every change to every service in sort of synchronized fashion. Because again, we're going for robustness, we're going for speed, and the coordination is too hard. We also agree that asynchronous service models, trying to develop asynchronous algorithms, is difficult for programmers. It's not how we're trained. We're trained, in fact, the requirements come to us saying, here's step 1, here's step 2, here's step 3, here's step 4. That's how the customer describes it to us. And so that's how we program. Even though if you really probe at it, maybe step 1, 2, and 3 can be done in parallel. It's all precedence to number 4. Go check the credit card. Does he have the right balance? Do you have goods in stock? Is this a valid customer? You can do all those validations really quickly in parallel and then put it all together in a final step. But again, it's described that way, we code that way. We don't think about it too hard. And again, it's hard for programmers to adjust to. So I have a colleague, and this is Chad Fowler, who's the CTO at 6 Wonderkinder now. He and I happened to be on the stage here in Dublin at the Web Summit a few years ago. And we're both talking about microservices. And he goes first and he talks about microservices and he says, yes, and you should use synchronous as your default. Because it's basically hard for the programmers. And most of the time it's going to work fine for you. And that helps their productivity. And of course I stand up right after him and says, yes, Chad's all these wonderful things, but he's an idiot. Because he should use asynchronous services. Because you want that robustness. That's why you're there in the first place, is try to get these robust algorithms. So take time, teach the programmers how to do this, move in that direction. I want that decoupling. You know, at the conference in Berlin a couple weeks ago, I got to go first, and Chad got to go second. So unfortunately, somebody actually tweeted this to Chad, and he was on his way there, and he had his corresponding slides down. And actually, it's interesting. The answer is not one or the other, but as Chad has developed his system at 6 Wonderkinder, it's a hybrid. Yeah, so a few times, yes, things have to be a certain sequence. But most of the time, you'd rather have something that's asynchronous. And his system is a little bit synchronous, but more asynchronous than not, because he's running lots of things in parallel. So it's basically kind of a hybrid situation. But you should not underestimate how hard it is for your programmers to think this way. How hard it is for your programmers to debug a system that's truly asynchronous, having lots of moving parts. These are complex systems we're building because that's our domains now. We're not trying to do payroll anymore. We're doing recommendation engines. This is harder stuff. So in the synchronous world, the asynchronous world, I tend to think in terms of this sort of analogy. I call it rapids, rivers, and ponds. This is actually, and I've shown this picture here a couple of times, but this is kind of my sketch. I was actually playing with my new iPad. I was flying across country. And this is sort of my analogy of what I'm trying to build. It sort of starts out by saying, in an event-based system, you want to move basically from a concept of an entity-related database for operations. You want to kill that idea. You want to go to the concept of an event system is your operational system. It's a series of events, not entities. That's hard thinking for most design people. So it's a series of events. And I want to wrap it. So I want every one of those events on a pipe that I can look at and measure and count and do everything we talk about there. But I want everything on that thing. Now that's a lot of messages. So you use something that has relatively high capacity. But you could pull off these messages and put together a theme, a river theme, where you basically, this is where you typically hang your typical services off this river, because these are basically messages that are related to each other in some fashion that your service is probably interested in. So pull it off into lots of different rivers, but again, they're events. And yes, there is a need to sort of maintain entity information at some point. I call that a pond because it's basically a stagnant piece of information. You can't tell when necessarily a piece of information changed, but the fact this is the current address of somebody, whether this is been address for 10 years or 1 year or 2 minutes, you can't really tell from that if this is not event-based. But you have need for those for reports and the like. But that's where you put your static databases. And that's where I believe that, in fact, for reports, you know, the reporting databases, the sort of data warehouse stuff, relational stores make a lot of sense. Asynchronous service tends to have this sort of architecture. You have a bus, you have a set of service sitting on the bus. And really the algorithm is different because the service basically expresses a need to the bus. I have a need. I'm not sure anybody's listening. And that's the part that's hard to design those algorithms. You got to think about an algorithm that says, I'm going to ask a question. I may not get an answer. I need to have some sort of default in my mind. Now, there could be people out there listening. They will listen for this particular need. You don't know how many there are, but it's okay. And they'll express solutions to this need. They may decide they're not going to answer the need at all, or maybe have multiple options for you, or have a single option for you. You express these options back to it. And the original service will pick these things up, sort through the ones he likes best, and choose. So this is sort of an architectural pattern for this sort of asynchronous system. Again, not your typical algorithm. What we like about this, and why we've used it in several different clients, is it's easy to add new variations. I put a purple service. I put purple service number 2 on the bus. The rest of the guys don't have to even know it exists, including purple service number 1. It can sit there, give its own answers. If they're better answers, the solution can pick it up. But also, the purple service could fail, and my system just runs degraded. Maybe I'm not getting the best answers for the client. Well, best was always kind of relative anyway. I'm guessing anyway. But yeah, I'm running degraded. And again, I can be aware this has gone down, but in the meantime, I'm still working, which is very important for us. So we like the architecture of those perspectives, which is why I keep pushing asynchronous with companies I work with. All right, third challenge. There seems to be an emerging confusion in my mind between microservices and functional programming. And I can't reconcile it yet myself, but I'm finding some very interesting behaviors here. First of all, in my mind, microservices were a lot like object-oriented classes. You know, they have one job, it's as small as possible, it does something interesting. It encapsulates, it actually encapsulates, in this case, its database. It never gives away its raw data. They always try to publish conclusions on the bus. So it kind of like OO classes. So I set it up that way. You just said that, just said that. But closure. And we use closure with the companies I worked at, and it loves shared data, which is like the violation of complete encapsulation. But like shared data because it's largely immutable. And you sort of set up systems like this. We set one of these up at the Daily Mail, where we basically rewrote and put publishing in the front end with a series of services like this. We started with basically this side, we started with some JSON formatted articles, and we wanted to create HTML formatted articles. That's how you render a front page. And so it's like one of those series of transforms. When you start looking at these transforms, you look at the data being passed between them, and it's like a map of an array of maps of arrays, of hashes of maps of arrays. It's not a data structure that any other person would want to use. There's no use publishing that service as an interface to anything else. It only kind of makes sense to the next transform. And so I kind of question myself, says, does it make sense making these into microservices? So, here's kind of the scorecard from 3 companies I've worked with, starting with one couple in London, and then the one in California. And we almost had 3 different answers to this question. So I'm going to show you where they came out on this question, in terms of like number of services, the languages they use to write these services in, and sort of how they couple these services together. Synchronous, asynchronous, and the like. So we start out with Forward. We were doing microservices back in about 2008 at Forward. We tried to do them about 2007. They got shut down by the CTO. CTO left. We did them anyway. So we have over 300 services there running at the time when I left. That was several years ago now. We wrote them in Ruby, we wrote them in Node, we wrote them in Clojure. We wrote some in R because we're doing traffic analysis. So lots of different languages, we took advantage of that. Originally, services were basically kicked off as cron jobs because they were background processing things, very, very tiny things. Read a Google report, run one type of analysis, publish results. If it was a different type of analysis, we wrote a different service. Even though it was the same Google report, maybe even for the same client, different analysis, different service. Then we moved to more RESTful things. We were chaining them together more often. And then we actually went to a bus-oriented structure. In fact, we used the Kafka bus, which is the open source from the LinkedIn guys. Really, really high capacity bus. 100,000 messages a second. Sometimes up to 250,000 you can read their stuff. I mean, you can't flood that bus. It's really, really difficult.
More than 10 million.
Huh?
More than 10 million.
No, more than 10 million. We gang them together, yes. Yeah, so massive capacity bus used by LinkedIn. So, it's industrial strength stuff. So that's kind of where a lot of the microservice thinking that I've talked about over the years has come from. So I went to the Daily Mail. We use two main languages there. We use Clojure for basically doing the rendering of the pages for the Daily Mail. Because again, it's data transfer from JSON structures into HTML. We wrote a lot of Node.js stuff, watching the service, watching the various things, monitoring traffic, counting article clicks, how powerful an article was, showing that to our editors. Interestingly enough, we had 3 Clojure services, which span like 4,000 lines of Clojure. And that's like, one of them had over 2,000 lines of Clojure code in the service. That's, in my world, that's not a microservice. Sorry, Adrian, it's too big for us. It's like, 2,000 lines of Clojure is a monster. I mean, you can move the world with 2,000 lines. By the way, that 4,000 lines of Clojure replaced 130,000 lines of Java. Nice. Doing the same job. So it's a silver bullet for that sort of application, but it's very powerful. The Node.js, there were dozens of them. And the average size of these Node.js services was like 14 lines of code. They're tiny. They do one thing well, and they're off for something else. There is no concept of running code libraries for these things, because it's just 14 lines of code. Why would you try to pull anything out? These were in Q because it seemed to be good enough, rather than move to a Kafka bus. So that's where they were. And finally, we go to my California startup that I went to. We started out with doing things like, this is a sort of picture, recommendation engines and the like for various services. Clojure is our language of choice for this company for a couple of reasons. One is it's obviously a very powerful language for doing a lot of stuff. Very complicated things, it's very good. And second of all, it actually attracts the best programmers. Sorry, no people. Let's say it attracts really good programmers. If you can get master Clojure, you're pretty good. Interestingly enough, we started about 25 microservices and the numbers started dropping. Because they were saying, why am I separating these services? Let's combine them. And they're getting to be fewer and fewer now. They're more like something else going on. We did use some orchestration. Oh, I didn't fix the spelling of that, sorry. There's some orchestration, which means they are chained together in fashion because you're passing one structure to another, to another, to another, which is not a coupling I like. They did RabbitMQ for traffic analysis, but it's really a small part of the system. So 3 different answers with Clojure. It says, Clojure makes a wonderful microservice. Well, if it's really a lot of Clojure code, and then why would you bother? I mean, 3 different answers from 3 different very, very good groups. So I'm not sure where that stands yet. I'm very confused about this. I do have some hope that I may get a glimmer of a way that this all fits together, and that's with the emerging of this language Elixir. And Elixir, if you haven't heard about it, is basically a functional language written on the Erlang VM, which means there's going to be thousands and thousands of little processes running around, written in Elixir, which kind of sounds like microservice world to me. And I'm kind of thinking that the more I understand this, the more I may get an idea of how microservices and functional programming actually fit. So that's kind of my 3rd challenge. My 4th one, architectures and frameworks. By and large, they don't exist. So it's kind of like, what is the way to get started? Give me some good examples of how to use and build microservices. They don't exist yet. The good news is some of them are starting to come into play. Adrian Cockcroft and what he's done at Netflix has been pretty amazing. I mean, Netflix built everything with microservices. By the way, they tend to be more synchronous than asynchronous. They tend to be much larger than my 14 lines of code. There's several thousand lines of code. But one of the things Adrian did say about this when he was in Berlin is a microservice in his world is something one programmer can understand and can be responsible for. It's not something I have to have 5 or 6 programmers to get together to figure out how to make it work. It's one programmer's effort. And they maintain it accordingly. But the nice thing about Adrian and what he's done was, of course, Adrian then open sourced all this code. There's 440 open source projects coming out of Netflix. It's a very, very powerful stuff. The Department of Defense is using Netflix software in the US to build complex systems. He cited 3 or 4 other clients who are using all this Netflix framework. So if you want some industrial strength applications, you want to be a large company, you have to worry about this stuff. This is not a bad place to go look and see how they did it and pick up the code and make it work. Because it's an extremely reliable system. They tend to deploy very aggressively. Their solution to some of Adrian's things is when they deploy new software, they take some of us, who are Netflix users, and they put us on the new system. And the marketing guy grabs an arbitrary number of us and puts us on the new system, and if it seems to work, good. If it doesn't work, they put us back on the old system. But they're trying it live with real people. That's how they test the things. Not unit tests, not analysis of that stuff. Put people on the live system, see what happens. So it's emerging stuff. There's also some emerging stuff in the Node community about microservice enabling frameworks. So it's some new things coming, but by and large, we really are missing those models and we need them. Challenge number 5. We don't have a design pattern book. I was hearing a lot of very interesting patterns being talked about in Berlin a few weeks ago, which is good. We're starting to talk about that stuff. But there's no book yet. There's no book I can look at where the design patterns are in there. This is how I solve this problem with a synchronous algorithm. This is how I solve it with a synchronous algorithm. Here's how I should report information. You're hearing a few of us talk about this evening. There are lots of people talking about it in Berlin. But nobody's sort of put all these together into a nice book that we can wrap our covers around.
Ross is writing a book on that.
Who is?
Ross Morales is writing a book on that.
Be interesting to see his book.
Anti-fragile software. It's like a lean book.
Yeah, so there's books coming, but until I see them and be able to use them, it's not a gang of 4 yet. Another gang of 4 book. The goal, sort of the nice thing that's happening though is we are getting together talking about this stuff. So I think the information is being exchanged in doing this. So certainly we have conferences. We're here at Meetup tonight. There's meetups going on in California and Berlin and all sorts of other places. And the good thing is we're getting together talking about this. And so, I was able to attend this along with Richard last couple weeks ago. Heard lots of interesting stories and heard lots of different stories. Which kind of leads me to the last challenge we have, which I consider to be challenge number 6 through N. That is, what is a microservice? You're hearing all sorts of answers. I don't want to be a guy standing here and says, you're not a microservice unless you look at the following. You're not a microservice unless you're following the books that are coming out. I think that's kind of a dead strategy. We tried that with Agile. We tried that with patterns. It's not a fruitful thing to do. Rather, when we talk about microservices, we need to be more explicit what we mean. We need to sort of describe what we're talking about in more universal terms. We need a language to talk about this stuff. We need some sort of taxonomy. I'm looking for something that sort of says maybe at some level, let's talk about the synchronicity. How much are you asynchronous versus asynchronous? Maybe it's a sliding scale even. You sort of slide your slider on the scale and say, here's where when I develop my microservice, this is how many are asynchronous versus synchronous around their primary API. What's the average size of service? And how many do you have of these? Because I kind of think if you had like a 1 to 10 ratio in a little graph here, you have 10 lines of code in one service, that's microservice. You have 100 lines of code, you have 10 services, you're micro. If you have 1,000 lines of code, you have 2 of them, you're probably not micro. If you have 100 lines of code and have 100 services of that size, maybe you're nano? I don't know. But some way to sort of reflect how many you have. So charts like Adrian's show, it says, here's how many services I have, here's their average size. That gives me a picture of what he's developing. Versus 14 lines of code like I saw in Daily Mail. And I think also it's important to get a feeling for the database, because the database will be the thing that people will forget when they start doing microservices. A lot of things we forgot when we started doing Agile about how Agile is supposed to work. But I'll almost guarantee the first thing they'll forget is, oh no, one database is fine. We can't change the database. We can work with one central database. That'll be easy. I want to see that ratio. Tell me how many databases you have versus how many services you have. And if it's not like, I got 2 databases and 500 services, it's like, yeah, you're not micro. You're not micro in the least. But I want to see those sorts of things, because otherwise the label really means nothing. So that's my list of challenges. I am excited to sort of see so many people working in microservices. It's also very, very sort of gratifying to see the variations, that how many different ways people can attack this problem, and exploiting the technology readily. I do think this is the way that you're going to see a lot of new startups. I already can note not only your story, but I've seen other stories that said, here's my gigantic application. It seems to be Rails these days. It seems to be the one they want to kill. And how I carve it up into lots of small things. I think this will be a recurring pattern in the near future, because we are having this sort of systems. And that's pretty much my story. I know it's getting late, but I've certainly entertained questions, and if you want to hang around a little longer, I can stick around as well. But any particular questions? What's going on in the microservice world?
Love the talk. If you break down everything to the database, which is exactly what we're doing with all of our new services, which I feel great about, one of the reasons though we haven't broken down our old big monolithic database is that there's a huge amount of other stuff downstream, basically reporting for our finance divisions and everything. If we start pulling that out into lots of small databases, we've got to then pull it back in at some point so that we can do aggregate reporting on everything. Do you have any thoughts on how to manage that?
Yeah, that's basically in my model, that's a pond.
Right.
And I think ponds make good reporting databases.
Right.
So we separated, a long time ago, we separated the operational stores from the reporting stores.
Right.
Because we know we organize them differently, we optimize them differently, we have different traffic demands upon them. I think that separation is still good. I would just kill the operational relational database.
Got it.
I would kill the entity-oriented operational database, change that to an event store. I think the other one, I'm not willing to tackle that right now. I think reporting is fine, it works against it. I mean, SQL queries are really good for reports because that's what we care about. That's fine, that's great technology for it.
Right.
Now what I would do is I tend to write services that will pump their little, CRUD transactions into the operational store, the database down there.
Yeah.
Because they're sitting on the same rivers, they're sitting on the same rapids. They say, oh, I changed something. Well, let me make sure I update the reporting database about that. So I'll turn that into a CRUD transaction. But I'll probably have dozens and dozens of those services as I see things changing that will pump into the cache in that store.
Wow.
Also, occasionally when I do write to a database, I may need to take that database with the key value store, turn around, pump that periodically back to the data warehouse as well. So I think that's certainly something valid you can do in the process as well. But it's definitely going to kill the operational version of a large database. That's death.
Yeah, I'm one of the few people around here who works with Clojure, so it's interesting to see that you actually have much more experience of Clojure than I do. But it turns out that in recent times, things have changed in the whole Clojure and functional programming and immutable data world. And one of the main catalysts for that is Datomic. I don't know if you're familiar with Datomic.
Oh yeah, quite familiar.
Essentially, Datomic is a database where every time you have new data, it just adds to the database, right? And you never have to do re-indexing. It re-indexes just with new data. And it changes the whole dynamic. If you have, and this covers maybe 95, 99% of business cases, it's where you have one write for every 100 reads. And I think that some of the things that the guys were talking about earlier, basically for every time they write to the database, they're reading 100 times out to different places. And because of the immutability of the database, the readers of the database can actually run the query engine and the SQL engine, the equivalent to the SQL engine, inside the client process. Right? And all you do is just go to storage, go to memcache, just get new values of the updated information.
But
that changes the whole dynamics of what you're talking about. Like what you're talking about is 100%, like these things about what you're talking about is exactly what, I don't know if Russ Miles has seen your stuff. Russ Miles is one of the, you know, Russ is one of the head guys around Europe about this stuff, right? And he's synonymous with this. Now, he has been piloting this thing for simplicity, but it really takes your questions and your challenges and those things to be addressed. And people are addressing them, but I think that, you know, things like Datomic and things like
if I go look at the California company, I got a couple of closure core contributors on that.
Yeah.
I mean, they're still struggling with the concept of how to do microservices. I think Datomic really works well for the reporting side of it. Yes, I can build a reporting base, and I can create a pond with that that doesn't forget the fact that it was a series of events.
Yeah.
That's very nice, but they're still not trying. It's still the little ones working independently. They haven't figured out how to carve that up that way. They don't think it's necessary to send a carve it from microservices.
No, that's what I'm saying. Your challenges are really, really valid, and it's not just for microservices, for the whole area of functional programming and that whole movement that Clojure is.
Yeah, and I'm not familiar enough with Clojure to sort of argue about that point. But
So
I think
we have slightly overstayed our welcome a little bit. So I think we're going to wrap up. We will continue the discussion over a few pints in the Schoolhouse pub, if you're interested. So thank you very much, Fred.